A rate of change refers to how much the output, or f of n, changes from one output to the next compared to how much each corresponding input, or n, changes. If n is changing by 1 each time, then we only need to find the common difference between f of n and f of n plus 1. The notation f of n and f of n plus 1 simply refer to the output f of n that you have now and the output f of n plus 1 that will be next. In this example, notice that f of n is increasing by 2 at each step in the table, and in the graph, f of n is going up 2 each time n moves horizontally by 1. In the task you did today in class, Don't Break the Chain, you were asked to calculate the number of emails people would receive on any given day based on a fast-growing pattern. You were also asked to write a recursive equation and an explicit equation based on the information in the story. The first step is to recognize how the pattern is changing. Is the same number being multiplied times the previous term? If it is, then that number is called a common ratio, and the pattern represents a geometric sequence of numbers. If you can identify the common ratio, you can also write the recursive equation. You began writing recursive equations by using the phrase now equals previous times the common ratio. Mathematicians use the same efficient way of writing the recursive equation for geometric sequences as they do for arithmetic sequences. The only difference is that they are multiplying instead of adding. In this exercise, you should practice writing your recursive function in the same way a mathematician would, by using the notation f of n and f of n minus 1. Let's begin by looking at a sequence, 7, 21, 63, 189, and so on. You can multiply the previous term times 3 to get the one you have now, or you could take the term you have now and divide it by the previous term to determine that 3 is being multiplied each time. Therefore, 3 is the common ratio. If the common ratio in your pattern is 3, the recursive way to think about the equation would be the one you have now equals the previous times 3. You could also write now equals 3 times the previous. A mathematician would write f of n equals f of n minus 1 times 3, or f of n equals 3 times f of n minus 1. It is also important to include the beginning number of the sequence. In this case, it is 7. The recursive function for this sequence is f of 1 equals 7 and f of n equals f of n minus 1 times 3. You can see the common ratio in the explicit function. The common ratio describes how the pattern is changing, but because we are multiplying each time, the number grows very quickly. Again, the explicit function is the rule that allows you to take any input n and turn it into the corresponding output f of n. To think explicitly, it's not enough to just look at the sequence. You need to look at the inputs and the outputs together. It's also helpful to notice the pattern of how we derived each term. The pattern in the outputs looks like the function rule should contain a 7 multiplied by 3 to some power. The number of 3's is 1 less than the input number, so the explicit rule is f of n equals 7 times 3 to the n minus 1 power. If you are concerned that the first term is 7 times 1 instead of 3, you may need to recall that 3 to the 0 power equals 1. Actually, any number except 0 raised to the 0 power equals 1. Note that the common ratio appears as the base of the exponential equation. This section is a review of the homework you were assigned in the Ready, Set, Go from 1.4. If you are having trouble finding the recursive function or the explicit function, look back at the helps, hints, and explanations from the Set section of the 1.4 Ready, Set, Go assignment. Recall that functions can be represented in several different ways, including lists, graphs, contexts, or models. If you are given an arithmetic sequence written as a list of numbers, the list represents the outputs of the function f of n. The inputs, n, are just the term numbers. In order to make a graph of the sequence, you will need to number each term beginning with 1. Let's do an example. Graph the sequence 1, 5, 9, 13. The points you will need to graph are 1, 1, 2, 5, 3, 9, and 4, 13. Remember that the first number is the horizontal move and the second number is the vertical move. This graph shows how to graph the point 4, 13. Sometimes you will be given a context that describes an arithmetic sequence. Then you will need to figure out the sequence of numbers before you can make a graph or write the function rules. For example, John pays $5 per month for his phone bill plus $1 for each text message. If John sends no text messages, he will pay $5 for his bill. After the first text message, John will pay $6 for his bill. His bill will be $7 if he sends 2 messages. Therefore, the sequence will be 5, 6, 7, 8, 9. You would graph the points in the table shown. Remember that each point is represented by the numbers n, f of n. If you are given a geometric model, you will need to count the dots or figures in the model to figure out the points that you should graph.